Hello students, in last period we see what is meant by order and degree of the differential equations. That is the first point in the chapter. The second point is formation of differential equation. Now we have to given the solution of differential equation or solution in terms of variable and constant, that is f x comma y comma c1 comma c2, that is Cn. These are the constant, x and y are the variable. The equation consists x and y variable and some constant C1, C2, C3 dash dash Cn. And after eliminating this constant, we get the differential equation. And this elimination of arbitrary constant by taking differentiation. Suppose y is equal to mx. Here m is constant, y and x are variable. This equation consists one arbitrary constant. The difference between arbitrary constant and constant, the arbitrary constant means if we change this arbitrary constant, then x and y does not affect on the change. For example, how many numbers or the numbers which divisible by 2, suppose we take twice n is equal to 1, which is also divisible by 2, n is equal to 2, 2 into 2 is 4, divisible by 2. Now we take n is from 1, 2, 3 different, therefore such a type of constant, this n is called as the arbitrary constant. But if twice I plus 1 is equal to 15. Here I is the constant, but in place of y, we take 7, then which is correct. Otherwise, this equation does not correct. That is, this n is arbitrary constant, and this I is called as the only constant. Here, this equation consists of one constant. Therefore, take the first order derivative. That means after formation of differential equation, if this solution consists of one constant, then we get first order derivative. That means take 1 times derivative. Differentiate with respect to x, left hand side dy by dx is equal to m is constant and derivative of x is 1. That is m. Equation 2. Substitute value of m in equation 1, then y is equal to m is dy by dx into x. Therefore, x dy by dx minus y is equal to 0, which is called as the differential equation. By eliminating arbitrary constant m, here this equation consists one constant, therefore we get the order of this differential equation is 1. In physics, we form the differential equation of simple harmonic motion. This equation is second order, that is d2x by dt square is equal to minus omega square x. Now, this is the second order. Now we take another example. Y is equal to ax plus b. Now this equation consists two constant, arbitrary constant. Therefore, take 2 times its differentiation. Now first this given equation, differentiate with respect to x, left hand side dy by dx is equal to a plus derivative of b is 0. That means by taking first order derivative, b is eliminate. Again, differentiate with respect to x, d dx of dy by dx is equal to derivative of a is 0, that is d2y by dx square is equal to 0, which is the second order differential equation, because this equation consists two constant. In this way, by eliminating arbitrary constant, we solve some example in exercise 6.2. Exercise 6.2, the question 1 is obtain the differential equation. I write shortly, by eliminating arbitrary constant. This arbitrary constant, most important, x cube plus y cube is equal to 4x. Now, given equation contain one constant. A is one of the constant. Therefore, we get first order differential equation. Now, we eliminate this A by taking differentiation only one times because the constant is one and only one. Given equation x cube plus y cube is equal to 4ax. Differentiate with respect to x, the derivative of left hand side, thrice x square plus thrice y square, derivative of y with respect to x, dy by dx, which is the function of function, is equal to 4a, which is the equation 1, equation 2. Put the value of 4a in equation 1, then we get x cube plus y cube is equal to bracket 3x square plus 3y square dy by dx, that is the value of 4a into x, then x cube plus y cube is equal to, multiply this, 3x cube plus 3xy square dy by dx. 3x square and 3x cube and x cube. If we take this x cube in right hand side, then we get 2x cube. 3x cube minus x cube plus 3x y square dy by dx, same, and this y cube is a negative, that is minus y cube is equal to 0. That means the equation is 2x cube plus 3 y square dy by dx minus y cube is equal to 0, which is the differential equation. Its order is 1 because this equation consists one and only one constant. Second example, x square plus bx plus c. Now this equation consists two constant. That means given equation contain two constant a and b. Therefore, we get second order differential equation. If we get second order differential equation, we differentiate two times of the given equation. First write given equation ax square plus by square is equal to 1. That is equation 1. Now differentiate with respect to x twice ax plus twice by into derivative of y is dy by dx is equal to derivative of 1 is 0. dividing both sides by 2, then we get ax plus by dy by dx is equal to 0, equation second. But this equation consists to constant, again differentiate with respect to x. Derivative of first term is a into derivative of x is 1 plus b bracket. Here first function is y and second is dy by dx. Y derivative of second function d2y by dx square plus dy by dx derivative of first function is also dy by dx is equal to derivative of 0 is 0. That means a plus b bracket y d2y dx square plus dy by dx into dy by dx bracket square. Now these two terms are not equal. Here derivative of y dy by dx with respect to x, and here dy by dx bracket square. That is the different terms. Here second order derivative, first order derivative and its square is equal to, this is the equation third. Now we eliminate the arbitrary constant AB in equation third as well as AB second, first, AB. These three equations are linear equation in terms of A and B, and eliminate A and B by using the consistency property in determinant we are studying last year. If eliminate A and B, then coefficient of variable and constant term is equal to 0. Determinant of coefficient of variable. First equation, coefficient, here variable is a not x square because we eliminate A and B. The coefficient of A is x square, coefficient of B is y square, and constant term is 1. Second equation, coefficient of A is x, coefficient of B is y dy by dx, and constant term 0. Coefficient of A is 1 and coefficient of B y dy by dx plus dy by dx bracket square, and constant term is 0. This determinant is equal to 0 if these three equations are satisfied for the same value of A and B, then this determinant is equal to 0. Now after solving this determinant, therefore x square bracket 0 into this term is 0 minus 0 minus y square bracket 0 minus 0 plus 1 bracket x into this x bracket y. Now here y into d2 by dx square, y into d2y by dx square plus dy by dx. Now 1 x into this minus 1 into y dy by dx is equal to 0. Then first two term 0, remaining term xy d2y dx square plus x dy by dx minus dy by dx bracket square. dy by dx bracket square. Here y into d2y by dx square plus dy by dx bracket square, y into d2y by dx square plus dy by dx bracket square minus y into dy by dx is equal to 0, which is the final answer. Xy d2y by dx square plus x dy by dx bracket square minus y dy by dx is equal to 0. Now we get the second order derivative, that is d2y by dx square, which is the second order derivative. Now in formation of differential equation, degree of the differential equation is always 1. d2y by dx square is a degree is always 1. The equation is first order, second order, but degree is always 1, which is the second example. Third is y is equal to a cos of log x plus b sin of log x. This equation also consists two constant. Therefore, we can take 2 times differentiation and we get the second order derivative. Now, first write given equation. Y is equal to a cos of log x plus b sin of log x, equation 1. Differentiate with respect to x, left hand side, dy by dx is equal to minus a sin of log x, again derivative of log x is 1 by x, plus b cos of log x, again derivative of log x is 1 by x. Now the 1 by x is common, take left hand side, x into dy by dx is equal to minus a sin of log x plus b cos of log x. Now this equation consists two arbitrary constant. Then we take second order derivative again. Differentiate with respect to x. Here u into v, first term x d2y by dx square plus dy by dx derivative of x is equal to 1 minus a into cos of log x, and derivative of log x is 1 by x. Here minus derivative of cos is minus, therefore minus b sin of log x into 1 divided by x. Take minus 1 by x common, in bracket a cos of log x plus b sin of log x. Now this bracket and given equation 1 or given a problems is same. In place of this square bracket we write minus 1 by x into y, then is equal to minus y by x, multiplying both side by x, then we get x square d2y by dx square plus x dy by dx is equal to minus y, multiplying both side by x, this x cancel, and last steps take x square d2y by dx square plus x dy by dx plus y is equal to 0. Again we get the second order differential equation. Highest order derivative term is d2y by dx square, therefore which is called as the second order differential equation. Degree is always 1. Now here we also apply the determinant method. we take our given equation is 1, first, second differentiation, third differentiation, and take the determinant of coefficient of constant a, b and constant term is equal to 0. But after taking second order derivative, we get the first term. Now this method can be applied y is equal to a sin x plus b cos x, as well as y is equal to e raised to ax plus y is equal to e raised to minus ax. Now next, fourth example, y square is equal to x plus c bracket cube. This equation consists one and only one constant, but after expanding this, we get, after expansion we get the fourth term. Out of four, three term consists c, which is very complicated. That means we eliminate this bracket cube first, taking cube root on both sides. Cube root on both sides. Then y square raised to 1 by 3 is equal to x plus c raised to 3 raised to 1 by 3, that is y raised to 2 by 3 is equal to x plus c. Now we take one time differentiation, this is eliminated, which is the only one arbitrary constant. Differentiate with respect to x by using x raised to n, find its derivative. N is 2 divided by 3 into y raised to 2 divided by 3 minus 1. Derivative of y is dy by dx is equal to derivative of x is 1 plus 0. Then 2 by 3 into y raised to minus 1 by 3 dy by dx is equal to 1. 2 divided by y raised to 1 by 3 dy by dx is equal to 3 into 1. Multiplying both sides by 3. Also write 2 dy by dx is equal to 3 into y raised to 1 by 3. Now taking cube on both sides. Taking cube on both sides. Then left hand side is 2 cube is 8 dy by dx bracket cube is equal to cube of 3 is 27 into y raised to 1 by 3 raised to 3 is equal to 27y. Therefore final equation is 8 dy by dx bracket raised to cube is equal to 27y, which is the first order differential equation. Here dy by dx cube, I modified this, but this answer is also correct answer. But in last answer sheet, in text, the given answer is in this way. We modified this. Now in this period, last example we take y is equal to a into e raised to 5x plus b into e raised to minus 5x. Given equation y is equal to a into e raised to 5x plus b into e raised to minus 5x. Differentiate with respect to x dy by dx is equal to, this equation also consists two arbitrary constant, then take 2 times derivative. Here 5 a e raised to 5x minus 5b e raised to minus 5x. Again differentiate with respect to x d2y by dx square is equal to 5 into 5, 25 a e raised to 5x minus minus plus 25 b e raised to minus 5x. Take 25 common in bracket, a into e raised to 5x plus b e raised to minus 5x is equal to 25. Now this square bracket and equation 1 is also same. Then we write y, that is d2y by dx square is equal to 25y. Now this problem is very important for the MCQ, because suppose we ask y is equal to a into e raised to 3x plus b into minus 3x. Here e raised to 5x and minus 5x, then we get 25. Its answer is d2y by dx square is equal to square of 3 is 9y, which is the short key to MCQ problems. In this way, we solve a simple types of formation of differential equation. Next period, we solve some complicated problem or family of the curve form the differential equation. Okay.